Water is an amphoteric molecule. That is, it can act as both an acid and a base. Being that it's able to do that, it can even react with itself and auto-ionize. One water can act as a base and accept a proton from another water molecule which acts as an acid. So this water molecule accepting a proton from this water molecule gives us hydronium and then hydroxide. Of course, a quicker way of writing this reaction is to cancel out one of the waters and to replace hydronium with just a proton. So that water auto-ionizes. It breaks up into two ions, protons and hydroxides. Now this auto-ionization of water, it has an equilibrium constant, Kw, which is 1.0 times 10 to the negative 14 if you're at 25 degrees Celsius. This fact allows us to calculate what concentrations of protons and hydroxides we might find if we had just a solution of just water. If you had a solution of just water, if you just started out with water, then perhaps sometimes waters might break up and give you protons and hydroxides, but the concentrations of protons and hydroxides would be equal. And having equal concentrations of protons and hydroxides, and then calling those concentrations X, you could calculate that it's 1.0 times 10 to the negative 14 X squared, or X is equal to 1.0 times 10 to the negative 7. In a neutral solution, the concentration of protons is 1.0 times 10 to the negative 7, and the concentration of hydroxides is the same, 1.0 times 10 to the negative 7. So we can build that into our chart here. In a neutral solution, the concentration of protons is 1.0 times 10 to the negative 7, and the concentration of hydroxides is 1.0 times 10 to the negative 7. Now, it's a little awkward to deal with 10 to the negative 7s all the time. It's easier instead to deal with much smaller numbers, or bigger numbers in this case actually, where we refer to pH and pOH. pH is the negative log of the concentration of protons, and pOH is the negative log of the concentration of hydroxides. In a neutral solution, you have a pH of 7 and also a pOH of 7. Okay, so in a neutral solution, the pH is 7 and the pOH is 7 as well. Same values. What if, however, you had an acidic solution? Perhaps you had some just water and then you were to add some acid to it. By adding acid to it, perhaps hydrochloric acid, you would increase the concentration of hydroniums, aka protons. And by increasing the concentration of protons, that would also adjust the concentration of hydroxides. Having a high concentration of protons, and being that protons will sometimes collide with and react with hydroxides, that will decrease the concentration of hydroxides. We see that there's an inverse relationship between the concentration of protons and hydroxides. Because multiplied by each other, they give a constant. So increase the concentration of protons, that decreases the concentration of hydroxides by consuming those hydroxides. And so our concentration of hydroxides might have been higher than it was in our neutral solution. It's greater than 1.0 times 10 to the negative 7. And hence, our hydroxide concentration must be lower than it was in a neutral solution. It will be less than 1.0 times 10 to the negative 7. So, in an acidic solution, the pH is going to be then less than 7, and the pOH is going to be greater than 7. What if, however, we had a basic solution? Perhaps we had some water, and then we were to add some base, such as sodium hydroxide solid. That sodium hydroxide, it would dissolve within that water and produce sodium ions and hydroxide ions. Or, similarly, you could place ammonia into water, and that would react with the water and give us ammonium and increased concentration of hydroxides. Either of these bases would increase the concentration of hydroxides, and being that hydroxide reacts with protons to form water, having a high concentration of hydroxides would consume some of the concentration of protons. And so this would lower the concentration of protons. Or another way to look at it is, Proton and hydroxide concentration are inversely related. If one is high, the other must be low, because multiplied by each other, they give us a constant. So in our basic solution, the concentration of protons is less than 10 to the negative 7, and the concentration of hydroxides is greater than 10 to the negative 7. And so the pH would be greater than 7, and the pOH would be less than 7. Okay, please edit this in the notes. Now, we oftentimes refer to the pH scale. The pH scale deals with the logarithm of the concentration of protons. Now, most often we'll be dealing with pHs between 0 and 14. Now, if you had a pH of 0, the concentration of protons would be 1 times 10 to the 0, or just 1. But if the pH was 1, the concentration of protons would be 1 times 10 to the negative 1. So it would be concentration of protons of 1 versus 0.1. You see that each time that the pH changes by 1, the change in the concentration of protons is 10 times. And so if the pH is 2, and if the pH is 2, how many times more concentrated would the proton concentration be than if the pH were 0? Well, being that there's a pH difference of 2, there would be a 10 to the 2, or 100 times difference in the concentration of protons between pH of 0 and 2. Now, pH of 7 is considered neutral, and pH of greater than 7 all the way to 14 is considered basic. But it's also possible to have pHs which are outside the range of 0 to 14. As an example, if you had a pH of negative 1, this might be because you had a concentration of protons which was 1 times 10 to the positive 1, or 10 molar. Yes, it's possible to have concentration of protons greater than 1, hence pH can be less than 0, so it can be negative. And then similarly for pH in basic solutions, it can be greater than 14 in some cases. All right, so let's say that I gave you the concentration of hydroxides, and I asked you to find the pH. Now, concentration of hydroxides, protons, pH, and pOH are all related to each other via these equations. Now, you've probably written most of them down, except though you haven't written these down yet. The concentration of protons can be found from the pH. It's equal to 10 to the negative pH. And the concentration of hydroxides is 10 to the negative pOH. Now, let's say that I ask you to go from concentration of hydroxides to pH. So, in our problem, we have concentration of hydroxides is 3.2 times 10 to the negative 11 molar, and pH is not yet known. Now, you have two options to follow to get there. You could go from concentration of hydroxides into concentration of protons and then into pH. Or you could go from concentration of hydroxides into pOH and then into pH. Now, I think it's a lot easier to go via the pOH route. This involves just subtracting the 14 minus pOH. Whereas in the top route, you'd have to be dividing or multiplying sometimes by 1.0 times 10 to the negative 14, and that is an awkward number to deal with. So it's best to avoid it if you can. So to find the concentration, actually to find the pH from our concentration of hydroxides, find pOH, 10.49. Then subtract that from 14 to give 3.51. Thanks for watching, guys.